Hi there, everyone. Today we will look at part two on the fundamentals of fractions in equation form. This is specifically for the grade 9s and grade 10s. The topic is actually quite the same from the previous video. The only difference is that we will look at adding, subtracting, multiplying, and dividing fractions in equation form. Part one, we looked at it through expression. Okay, so just be careful. Expression, reduce the fractions to its lowest form. Equation, give answer for a variable. And that's the only difference, really. Okay. Some prior knowledge, I already went over this in the first video, but just to recap a little bit, understand fractions as a general understanding. Know that there is a makeup of a fraction consisting of a numerator and a denominator. Equivalent fractions look like something like this. 1 over 2, half. Basic number operations. Here you will need to follow BODMAS, okay? In some situations, and they are definitely linked. In some situations, the adding, subtracting, multiply, and dividing fractions, the application will change depending on the scenario. Multiplication tables or multiplication as a whole is very useful to help us reduce values, okay, or to see what the LCD, sorry. Simplify fractions. This is very important. We don't like to work with large values. In most situations, you will definitely reduce some fractions to its simplest form. Some of them cannot be further simplified. Okay, factors, it's not a big one in this video. Common denominators. In this situation, we have to find the LCD. LCD is a very similar concept to LCM. The focus over here is just that LCM on the denominator side. Okay. BODMAS, order of operations. We should know how to apply BODMAS in a sequential manner when working with expressions or equations. Algebra basics. Here we will actually see a linear equation. Okay. Have equal sign. If it has equal sign, that means y has a specific answer. Recognize simple algebraic equations. Here you will see it as linear equations. For some students in grade 10, or depending on the school, they will work with quadratic equations, but over here I strictly focus on linear. Here are the objectives or the goals or aims. In the previous video, all of these words were expression. Now we just look at it through an equation. Okay. Add fractions in equation form, you get the idea. Going down to divide, simplify all fractions, apply correct fraction rules within equation. I will show you what actually happens. We have some methods depending on the setup of the question, and some methods are just more convenient. Just a bit of a recap from the previous lesson as well. LCM is more of a general understanding in mathematics, okay? And it just refers to the lowest or the smallest number that two or more numbers can divide into. So let's look at 4 and 6. 12 is the lowest number that 4 and 6 can divide into, okay? Let's say, for instance, we have 3 and 7. What's LCM? What is a number that's still the lowest that 3 and 7 can divide into? 21. Now, LCD is just the fraction version of it, and the focus is specifically on the denominator. So it actually means LCD refers to LCM in a way, just on the denominator side. Okay. So in this situation, if we have 1 over 4 plus 1 over 6, the LCD, which is technically the LCM for the denominator, will be 12. You make your changes accordingly, so the denominator are equal. The makeup of fractions, I think we got the gist idea of this. So just be careful. The makeup of the fractions always consists of a numerator being on top. separated by this division line, and then we have denominator, which is the down value. Okay. The operators, be careful. These are the specific signs, okay, that we will use in order for an operation to take place. And each sign will dictate which method we will use, okay? We generally don't work with mixed fractions here in grade 10. Improper fractions is very common. You will see this. Let's look at the adding of fractions over here. Now, in the previous video, if you recall, it was strictly looking at it from an expression point of view. So we had one setup where it was non-variable, and the other one it had a variable. The idea in the previous video was just to take the fractions and reduce it to its lowest form. Over here, we need the variable because we are looking at it through an equation point of view. So we have to have x over here and the equal sign to show that something is equal to something. So there are actually three methods that we can use or apply. Method one, which is the standard one, is to get the bases, sorry, not the bases, the denominators the same. So we come back to our focal points from the previous video, LCD. For all of these denominators, 2 actually has a denominator of 1. It's just that we don't express it like this in a general setup. So we know that we have these three values, 5, 15, and 1. What's the lowest common multiple for these three values? It will be 15. Okay. Let's make the adjustments accordingly. 5 times 3 gives us 15. Times this entire binomial bracket by 3. 15 is already cleared for the LCD, but let's just put times 1 to show that we make some change at least. Okay, and that's what we have. So now we need to open up the brackets, okay? 3 times 3x will give us 9x minus 6. Okay, I'm going to give us a primary division line, which will be 15. This plus sign comes here. Be careful. Plus 3 is equal to 30. Oops. 30 over 15. And now in this situation, okay, we have the common denominator, 15. Multiplied, we have multiplied accordingly. Number 3, in the previous video, we did not have number 3 to clear denominators because we did not have an equal sign. So we have an extra step here. Clear the denominators and express the numerator as the equation. What it means, we will cancel these, and the numerator, which are these values at the top, will be the linear equation. Let's do it mathematically or in a correct manner. 9x minus 6 plus 3 is equal to 30. 15, we got rid of it. Okay, because the denominators are equal and we have the equal sign as well. Now we just solve for the variable x. Send all the constant values over the equal sign. When you send them over the equal sign, the sign itself for those values will change. 9x is equal to 30 plus 6 minus 3. 9x, if we do the operation over here, give us 33 divided by 9 divided by 9. X is equal to 33 divided by 9, which can be further simplified to 11 over 3 as our final answer for x. Okay, can you see? I hope you get the idea here. So that was method 1. Okay, get the LCD, cancel the denominator, express the numerator as the linear equation, solve for x. Method 2, very common method that most students use, okay? And it depends on the setup as well. Some setups are more convenient. This one might be difficult to use cross multiply. This one is just better. The setup is just convenient. So the idea of cross multiply is that you multiply two fractions over the equal sign. So if we have 2 over here, it will multiply this entire binomial bracket. Once you take that 2 and multiply the entire binomial bracket, You then introduce the equal sign afterwards. Okay. And then whatever you do on that side, you must also do it on this side. 5 times 7. Let's do the operation. Then you can see the picture. Let me write it like this so you can see what it looks like mathematically. I'm going to do it in black to show you that we introduce the equal sign immediately after we do the first multiplication. 5 times 7. Okay. So 2 times 4y, we open the bracket. 8y plus 6. Yeah, we can say, let's rather just stick with black so you understand. Ooh, that's not equal. 5 times 7, 35. Okay. Now we just need to move 6 over the equal sign because now we have our equation. And notice something. When we cross multiplied, we showed the equal sign and there is no denominator, which is good. Okay. So in fractions, we're always trying to get rid of the denominator in equation form. Okay, let's go with black again. So we have 8y is equal to 35 minus 6. 8y is equal to, what is this? Oh, 29. Okay, and that's it. That's all we have. So it'll be 8 over 29. Your final y answer in this case will be 29 over 8. I don't think we can further simplify this answer. So we just leave it as 29 over 8. Okay, very convenient. Let's look at method 3, which I call it elimination. Okay, and the idea of elimination is to actually get rid of this denominator. The setup is very convenient for method 3. Okay, so let's see what we can do. Once we get rid of the denominator using elimination, there will be no denominator, meaning that whatever is remaining, that will be the linear equation itself. So here's how you do it. Multiply it by 3. Also, whatever you do on that side, you must also do it with all the other terms or fractions on the equation. So this 3 will actually cancel this one out, which is great. What we have essentially is 5x plus 24, 27 times 3 minus 81. So you can take that 3 and also position it over here to still take into consideration of the negative sign. 81 equal 0. Move the constant values over the equal sign. 5x is equal to 81, becomes positive 81 minus 24. Okay. Now in this situation, we just simplify further. 5x. Okay. 81 minus 24, it should give us 57. Okay. 80 minus 20, you have 61, minus 4, 57. Divided by 5, divided by 5. Your final answer for x is equal to 57 over 5. We cannot further simplify this. Okay. So it's a very useful method. You can still use method 1 and method 2 as well for the setup. Okay. For example, let's say, for instance, you want to say 5x plus 24 over 3. Okay, and then you send 27 over the equal sign and you put it over 1. When you cross multiply, it will give you the same answer as well. Okay, we have 5x plus 24 is equal to 81. Very similar to the previous question. The only difference is that now we just shift the 24. 5x is equal to 57. And you divide by 5 and it gives you the same answer. Or primarily, you could also go back to the standard way and equalize the denominators, make the adjustments by multiplying the numerator values with the changed denominator, cancel the denominator, express your equation through numerator, and that's it. Now we look at it through a subtracting lens. Same situation, really. Only difference is that we have subtracting. Or subtraction. Same concept. Must have common denominator, multiply the fraction accordingly, cancel, solve for variable. LCD is this. 5, 3, 1. 15. I hope you can see it. So it'll be 15. I'm going to change this red, this one to black. 1. Let's make the changes. 5 times 3 gives us 15. This one times 3. Just be careful. This one times 5. Times 5. Times 15. Times 15. Cool. We have now multiplied accordingly. Now we just need to open up. 3 times 3x. 3 times negative 2. This results as 9x minus 6. Let's write one primary division line. 15 minus, because of that sign, minus 10 is equal to 30 over 15. Okay. Cancel the denominators, express the numerator as the equation. This is what it looks like. 9x minus 6 minus 10 is equal to 30. We got rid of the denominators. Send the constants over. 9x is equal to 30 plus 6 plus 10. 9x is equal to 30 plus 6 plus 10 results as 46. Okay. Okay. Then we have x is equal to 46 over 3. I don't think we can further simplify this. So we just leave it as 46 over 3. Okay. Over 9, sorry, over 9 as our final answer. Okay. It's pretty much. These are completely normal answers to get, so don't panic. Method 2, cross multiply. So you can see it already. It's just favoring. So this 10 multiplied by that. This 3 multiplied by that. So this is what it looks like. 10 multiplied by 5y multiplied by 4. Let's use the other one just for convenience so you can see what's happening. Equal. Now just be careful. This 3 and that negative sign sticks with the numerator. So it'll be negative 2. Okay. Let's reduce our values accordingly. Sorry, multiply first and then solve. And use the colors. 50y minus 40 is equal to negative 6. Send 40 over. 50y is equal to negative 6 plus 40. Let's do it over here. It's not conventional to write it next to each other. It's very important to write your equations or your sums going top to bottom. I just don't have space, so I have to get creative. So it'll be 50y is equal to plus 36. Divide by, sorry, not 36, 34, because that's a minus 6. So this one over here, minus 6 plus 40 gives us 34. Divided by 50, divided by 50, y is equal to 34 over 50. It can be further simplified if we divide by 2, hence 17 over 25. And that's our final answer for y. Okay. Awesome. So that was method 2. Method 3, elimination. We need to get rid of the denominator, and then we will not have any denominators, which is good. So we can solve for the unknown variable. 7 is giving us a problem. I'm going to multiply this whole fraction by 7. 7 multiplied by 5 with 7. So the 7 cancels that out. Essentially what we have is 5y minus 4 is equal to, no, not equal to, minus 35. 5 times 7 gives us 35. Equal 0. Comes there. Okay. Send the constant values over the equal sign. 5y is equal to 35 plus 4. 5y is equal to 39 divided by 5, divided by 5. Final answer for y will be equal to 39 over 5. I don't think we can, we can't further simplify this further. We leave it as is. Multiplying fractions. Okay. This is a gift question. Okay. Now, it's already, in a sense, in multiplication form, but I don't like this setup because I still want us to use this concept over here. So what I'm going to do is I'm just going to add another, how can I say, fraction on this side over here. Okay. Let's say, for instance, we have 4 over 5. Yeah. So now we have multiplication. In this situation, I'm going to multiply the numerator with the numerator, denominator with the denominator. What it looks like mathematically, it is going to be 4 times 5y plus 4. Okay? Over 5 times 3, which will be 15. But let me put it so you can understand. Is equal to 2 over 10. Let's reduce our fractions. 4 times 5y, 4 times 4 itself. So we have 20y plus 16 over 15 is equal to 2 over 10. So we are confronted with two options here. You can cross multiply, which is method 2, or you can get the denominators equal, which is method 1. I recommend cross multiply, okay, because it skips one step, no, 2, for step 1, or method 1 in this case. Cross multiply is this: 10 multiplied by that entire binomial bracket, okay? Then you introduce the equal sign. Same situation with the bottom one, okay? So what it looks like mathematically, let me show you. I'm going to write it on the left-hand side for convenience. So it'll be 10 times 20y plus 16, okay? Then you show the equal sign because you've done the first combination of multiplying. Then it will be 15 times 2. So 10, multiply these values accordingly. What we have essentially is going to be 10, what am I saying? 10 times 20. In this situation, it'll give us 200y. Oh, it's a very big value. Okay, and then plus 160 is equal to 30. Yeah, I just said we shouldn't work with big values, and then I go and put 4 over 5. Okay, so over here in this situation, we are going to send the constants one side. 200y is equal to 30 minus 160. Divide by 200 on both sides. Okay. Essentially, what we get is that y is equal to 30 minus 160. It will give us negative 130 over 200. Okay. And that's what it gives us as our final answer. Okay. We should actually reduce it further. I'm just trying to think for a faster method. I think for the time being, we should simplify. Maybe I can check it quickly just to make things easier for us. Otherwise, we sit and calculate forever. Let's see, negative. It'll be 130 over 200. Okay, so it gives us 13 of, oh, it's actually easy because you cancel the zeros. Wow, I did not see that. Okay, that was my blonde moment, even though I have black hair. So it's negative 13 over 20. I didn't see you can cancel the 0. It happens. Okay, so that's our final answer. Okay, it's quite a long procedure. Okay, let's look at dividing fractions. It's the same, really, as the previous question. The only difference is that we have an extra step where we need to change the sign and flip the values. Essentially, what it looks like is that we have 5y plus 4 over 3. Change the sign and flip the fraction, the numerator and the denominator. Okay, so essentially we have this 2 over 9. Okay, is equal to 4. Okay, multiply numerator with numerator, denominator with denominator. Okay. So in the previous question, okay, in this situation, we we had that 4 over 5. Okay. It's very similar to this question that we've done. Okay. Very, very similar. Okay, let's see now. Okay, numerator with numerator. Let's see what we have in this situation. So we just multiply the top values with the top, bottom with bottom. Essentially what we have, it will look like this. I will first express it so you can visually understand what I'm doing. Okay, let's open up the brackets accordingly, like that. Change the color for, I don't know, reference. 10y plus 8 over 9, 18, 27 equals 4. Now, in this situation, we can use two methods. Actually, we can use three, method 1, 2, or 3. I'm going to use method 3 by eliminating the denominator. I'm going to do that by multiplying this entire fraction by 27, okay? And this one by 27. This 27 cancels this 27, and what results as our almost finalized equation, it will be 10y plus 8 is equal to 4 times 27, which will give us 101. Okay, send 8 on the other side. Let me do it here at the top in this box over here for convenience. Okay, 10y is equal to 101 minus 8 divided by 10 on both sides. Okay, y is equal to, what is this? It's going to be 103. It's going to be, 93 over 10. And that is our final answer. Okay. So 93 over 10 is our final answer for this question over here. I hope you get the idea. Mixed form. This is where students panic. It's not difficult, really. The only difference is that now we just have more fractions and we need to apply the concept of board mass. So look at these. These are actually convenient for us. Okay, we can see divide and multiply. Look at these two over here. Okay, keep, change, flip. Okay, look at the red one. I'm going to make adjustments now so you can see it. 3y over 3, multiply 2 over 3, change the sign to multiplication, and then say 2 over 1. You flip. I'm going to change to black to show the rest of the fraction or equation. -4. Now, in this situation, it is super convenient. We have these all in multiplication form. So we can multiply all three of them at the same time. Okay. But before we do that, let me show you what it actually looks like. Multiply all the numerators with numerator, denominator with denominator. What it looks like, it's going to be 3y, okay? Multiply by 2, multiply by 2. Do you see it? Okay. And then at the bottom, we have 3 multiplied by 3 multiplied by 1. We get it over here. We write the remaining equation. Okay, plus 4 over 9 is equal to -4. Okay, let's make the changes now. So we're going to say 3 times 2 and again times 2. Okay. So over here, I like to do it. I like to do it like this. We say 4 and then you multiply 3 with 9 with 4. So it'll be 3y times 4, 12y over 3 times 3 times 1, 9, plus 4 over 9 is equal to -4 over 1. So in this situation, we can use method 1 or method 3 in this situation. Let's use method 3. We will eliminate. We can get rid of 9. And how to get rid of 9? Remember, multiply each of them by 9, 9, 9. Okay. The 9 will cancel this one. This 9 will cancel that. But negative 4 will be multiplied by 9. Essentially, what we have is over here, because we don't want the denominators. This is the problem. That's why we use elimination method, okay? Or you can use LCD method, get the denominators all equal to 9, cancel, express numerator as the linear equation. Essentially, what we have is 12y plus 4, okay, because we got rid of the denominators, is equal to negative 36. Okay, that's pretty much it. So we're going to send the constants over. 12y is equal to negative 36 minus 4. 12y is equal to negative 40 divided by 12 divided by 12. Y is equal to negative 40 over 12. I think we can simplify it by dividing by 4. So it'll be negative 10 over 3. Okay, there's your final answer for the mixed form. Wasn't that difficult, just extra steps. And I think that concludes for today. I hope now you have a better understanding when using fractions to solve for a variable in equation form. I will be uploading some more content later on. Yeah, for the time being, I think this is a very good start, because most of the questions in grade 9 and grade 10 are on these type of situations. Okay, awesome. I will see you guys in the next video.